Hello, welcome to a video regarding section 1.6, which is on solving linear inequalities. So we're going to start by doing something pretty simple. So if you look at number 1, we have 4 inequalities, and we're simply asked to graph each inequality on a number line. Hopefully you remember how a number line works. You can see we have tick marks at a bunch of different integers like 0, 1, 2, 3, 4, 5, and of course -1, -2, -3, -4, and -5. Now we're asked to graph x is less than 2. Whenever you just see a less than, what you want to do, and actually let's go with red so it just stands out better. You're going to draw a circle at 2, but don't fill in that circle. Just leave it like that because 2 is not included. Remember, 2 is not included. And of course, we're going less than 2, so we're going to shade to the left. So pretty simple. And anything in the shaded region represents all values that satisfy the inequality. Of course, our inequality is x is less than 2. And notice how numbers like net 1 and 0 and all the negatives, those are less than 2, so this works. Now, in this case, we have x is greater than or equal to 3 for part B. So now the 3 is included. So we're going to actually still draw a circle, but then we're going to fill it in. So a circle, and then I'm going to fill it in. And then I'm going to shade to the right because we're greater than. Oh, it went away. Let's do it again. There we go. So again, that represents all values that satisfy that inequality. Now, in this case, we have a compound. These are called compound inequalities because they involve 2 or more numbers. So we have 0 included, 2 not, and shade in between. A little frustrating. I don't know why it's vanishing. There we go. And then x is less than or equal to 2. So we're going to fill in circle, go forever this way. 3, don't fill it in because it's not included, and go that way. And there you go. Now for number 2. So compound inequalities, let's have a further discussion about that. Sometimes we can use the word and to combine 2 inequalities. So in this case, x is greater than or equal to 0 and less than 2. Now that's a little weird because, well, actually, no, it's not really weird because it's just what's on part C. But what it means is that you want the intersection or what's common for both those inequalities. So of course, if you go less than 0, sorry, greater than 0, here's 0, you're going in that direction. Here's 2, you're going in that direction, but we only want the overlapping region. We're not going to unite both of those inequalities because if you unite them, then you actually shade everything. So very careful, and represents the intersection or overlap between the two. So let's take a look at this one here. X is greater than 5 and x is less than -2. This is a little weird, so bear with me. Here's 5, and we're going greater than, it's going this direction. Here's -2, less than, we're going that direction. The problem is there's no overlap. So there's no solution to this one because it's impossible for x to simultaneously, being at the same time, be greater than 5 and less than -2. Just can't happen. Now in this case, I'll do green so it stands out a little bit. You have 0 and you have 5. So you're going less than 0 and you're also going less than 5. Now in this case, my overlapping region is right there. Because I have the word and. We have to simultaneously satisfy both of these. So you must satisfy both inequalities at the same time because you have the word and. It's kind of like saying I go to Sacred Heart Prep and I live in Redwood City. Okay, so both those statements would be true, I guess, if you go to Sacred Heart Prep and live in Redwood City. So that's, you're looking for an overlap there. So both have to be satisfied. Now we'll look at the situation where you have the word or. Oops. Now this is just a union of both inequalities. So you actually are combining. So x is less than 0, we go this direction. X is less than 4, we also go in that direction. But since we want the union of it, we're going to shade everything. So only need to satisfy just one inequality. It's kind of like saying if you go to a restaurant, I'm going to have chicken or steak. You'd be happy with either one. If you get both, yeah, that's awesome too. But you only need one. Only need to satisfy just inequality, but both is fine. X is greater than -1, go in that direction. X is less than 3, go in that direction. So there's an overlap, of course, but we want the union, not just the overlap. So in this case, it's all real numbers. And by the way, for part A, we would say that our true situation is just x is less than 4, since that encompasses everything. And here, of course, we say x less than 0, because that's the intersection for part B of number 2. So we'll have a discussion on this in class, because it is a little funky. I think 4 is a little more straightforward. You're asked to write a compound inequality. So of course, x is less than -2, or x is greater than 4. Do not use the word and, because you can't simultaneously be less than -2 and greater than 5. Now in this case, we're in between the two, and of course -2 is included. Or if you so desire, you could write it like this. -2 is less than or equal to x, and x is less than 5. That'll also work too. One way if this helps, it's kind of corny, but you could think of this as two oars on a rowboat. And notice we're using the word or, kind of playing words there. Notice here, we're sandwiched between two numbers. Sorry, I can't really write well styles here. So sandwiched, and not sure if that helps. X less than or equal to -2, or x greater than 5, and of course -2, x, 5, but you have to use the equal sign for both. Now we're going to solve these inequalities, and what you do is solve like you're dealing with linear equations. It's not really that much different. You're combining like terms, you just want to isolate x. So if I move things around, I get -2x on this side and -8 on that side. Remember, I'm going to subtract 6x and then subtract 3, kind of move things around. Then you're going to divide by -2. Remember the hint here. You got to flip the inequality. I'm going to explain why we flipped in a little bit. And it's actually going to be a question in the Google form, so pay attention. We do get x is greater than or equal to 4. So if I put 0 right here in the middle, 1, 2, 3, 4, filled in, go to the right, and that's how you graph your solution. So anything that's bigger than 4, or 4 included, would make that would satisfy that inequality. Like for example, if I plug 10 in, I get 43 on the left side, I get 55 on the right side, it works. But if I plug 0 in, I get 3 on the left side, -5. 0 is not less than or equal to -5, makes no sense. So that's how you can check your work. You can check by testing values. So yeah, not too bad, right? Now, why do we flip the inequality when divided by negative? So you have to flip inequality when you divide by negative. But here's the thing. A lot of people sometimes just do it because they thought they were told to. Well, just a rule. No, there is actually a very good reason why you do it. I'm going to tell you why. So what if I decide to move the 4x from left to right? So I'm going to copy the inequality again. But what if I decided to do this? Which is fine. That's not a problem. If you want to do that, so be it. And then, of course, I'm going to add 5 to both sides. Okay. And then I'm going to divide by 2. Well, what do we get? X is greater than or equal to 4. You have to guarantee the same answer. So must guarantee the same answer regardless of how you isolate x. If you isolate x on the left side or right side, you must end up with the same thing. That is why we flip. So it's kind of like if you're driving to San Francisco, you can take Highway 101, you can take Highway 280. Different paths. Personally, I like 280. 101 sucks, but I don't want to digress. I don't want to focus on math here. But it gets you the same place, right? If I want to get to, like, say, a Giants game, I can take both freeways. But you have to end at the same place. So let me have you try part B on your own. So you may want to pause the video, and then I'm going to work it out very shortly. Okay, hopefully you paused the video and worked on it. You should get x is less than 6, and you're going to the left. And you can always test points, like if you plug 0 in, you get 3 is greater than -9, it works. Let's look at 6. If I distribute, I get 2x minus 8 is greater than 2x plus 1. Now this is tricky because the 2x is canceled. So you're stuck with this. That's a false statement. No way is -8 bigger than 1. So the answer is no solution, and you don't shade the number line. So nothing will ever make that work. You can put whatever you want. The left side will never be bigger than the right side. So it's just impossible. So sometimes that can't happen. Now, if you got the reverse, just so you know, if we had this, then you would say the answer is all real numbers. So something to keep in mind. Another way you could look at this too, if you like, we'll talk about graphing when we get to chapter 2. But if you graph 2x plus 1, hopefully you remember how that looks. That's y equals 2x plus 1. That's y equals 2x minus 8, which is way down here. Okay. Gotta be a little careful if I draw this. So here's another one. Y equals 2x minus 8. The problem is that this line is always below the other line, but the inequality is indicating that it's greater than 2x plus 1. So that's a problem, obviously. Let's wrap this up. Again, you want to isolate x. Isolate x in the middle. Totally fine. So if we're going to subtract 5, so I get -15, that's a -3x, plus or equal to 3, then divide by -3. But you're going to have to flip, so 5 greater than x greater than or equal to -1. So if I put 0 right smack in the middle, 1, 2, 3, 4, 5, -1 right there. Obviously, no one's included. 5 is not included, and I shade in between. Here's yet another one. I'm going to add 1. And actually, you may want to pause the video and then see if you get the same thing. Okay, so it's an or situation because we're one or the other. 0, 1, -1, -2, -3. There, go to the right. There, go to the left. Boom, there you go. Okay, last one. Number 9. So a certain type of temperature ranges from 18 degrees to 34 degrees Celsius. Write the range temperature as a compound inequality, then write using in Fahrenheit, which requires a conversion. Um, well, it's pretty easy. It doesn't say if it's inclusive, so we'll just say it's inclusive. I'll just add that. You're supposed to be told that, I think. But you know, that's how you could show the temperature range. If you do convert to Fahrenheit, what you do is you multiply by 9/5 and add 32. The formula is degrees Fahrenheit equals degrees Celsius, or 9/5 times degrees Celsius plus 32. So that's kind of nasty, but you do get some funky decimal there. Do it again. That's also a little nasty. But whatever you get for those, and actually I'll just use a little calculator here, just get this out of the way. 18 times 1.8 plus 32, get 64.4. Clear. 34 times 1.8 plus 32, that's warmer, 93.2. So you can also write like this. The degrees Fahrenheit, we're up top Celsius, 64.4, let's move back, let's go to 93.2. So there we go, pretty easy stuff. Okay, that concludes the video, and we'll do some practice next time we meet. Goodbye.